So I'm going to talk about the tools for soil health planning and monitoring, particularly picking up on sort of the coming together of two projects, one the Asda work and work funded by HDB and BBRO. So thinking about tools for soil health planning and monitoring, and I know you've all spent hours poring over that video, which launched the Asda handbook for soil assessment to bring some of those together this sort of time last year. And what we've done subsequently is look at that in practice and look at some data, which is what I will show you. But the key here is just being clear about what we mean and separating the difference between those soil physical, textural, soil formation properties, those things that soils have as their underlying characteristics, their character, that set the context. And Sarah talked, and we often do, don't we, about good potato growing soil and not good potato growing soil. Dominantly, we're picking on those characteristics there where we're describing that. That's about, it can include site factors too, such as aspect and climate. In that context, we then have an opportunity to shape and change the soils themselves through management, and it's those properties that are shaped and changed through management which are the ones that are the focus of soil health measurements. So to say, given this character of the soil, is it in good health? So we're not seeking to compare a clay soil and a sandy soil and say they need to be the same. The key is identifying what makes soils of particular types healthy. And traditionally, of course, what we've done, and the experiments at CUF continue to do really well, is explore how we might look at soils for fertility management purposes, to zone soils perhaps for sampling, certainly to learn how to do beautiful Ws, as we used to do regularly, to take those representative samples for making decisions about fields in a way that makes sense in terms of fertiliser management. And the zoning, of course, recognises that very few fields are even. There are some where one sample represents that soil really well, that field really well, but other fields where there are a number of areas or zones where we need to take those samples separately. But soil health goes beyond that and recognises the need here for that balance between an understanding of the physics, chemistry and biology. Now, there's not really good data linking any of these soil health parameters, certainly not the integrated package of them, directly to yield. There's some indication, some hints that perhaps it might be a little bit better if, and we certainly see with spring crops such as potatoes, that some of these soil health indicators, organic matters and others, are giving us perhaps some improvements in yield, but in some seasons rather than others. And it might be around in changes and improvements to those factors that affect the resilience of the crop, those yield stability things that run year to year, whether it's in terms of water availability and being able to buffer intense rain or drought, or whether it's in terms of improving rooting and consequently having an impact on things like nutrient use efficiency. So we're thinking of soil health here and defining it in that context of that balance between physical, chemical and biological properties. And the HDB work specifically set out to look for those sort of key indicators that might be used, might already exist, that can be used in combination. So the key here is not that we're trying to sample every zone in every field, but that a bit like we get summoned to the GP once about every 10 years to have our routine health check done. We might do the same with soils. Once in a rotation, we might be able to look at these soil health properties and see if our management is keeping the soil in good health. And that means going, we feel, to the same place each time. And we're increasingly able to do that because we have the ability through mobile phones and all sorts of other things that have crept out onto mobile devices that allow us to geolocate and relocate points. Of course, we've always been able to do it, and Mark and I will remember from hundreds of years ago, locating the corners of trials by lining up posts in the field, and the idea that if you only just triangulate from 2 points, you can pretty reliably get back to the same place each time. So it doesn't require anything fancy, but it requires good record keeping to be able to do this geolocation. The idea to locate a point, the deliberate circle there, it represents my experience of soil sampling in the field. We tend to talk about, and field plots are always square, but when you come to do sampling, it's really tricky to mark out squares and really quite easy to put a point or marker down in the middle, whether here it's my sample bucket, and stay within a certain distance of it. And so here we recommend somewhere around a sort of 5 metre circle that we go back to on that once in a rotational basis to have a look at soil health. We talk here now about combining measurements that we need to make ourselves in the field, those in-field scoring, and Mark's already done a marvellous demonstration of visual assessment of soil structure and how that might be used, things like earthworm counts, and also at the same time collect those bags of soil that Sarah has also shown you and send them away for analysis. But it's important not just to choose indicators and measure them, but to choose indicators that we can benchmark, that we can say, is this actually about right for our soil, for our location? And increasingly the importance here is to be able to link and benchmark by soil type, by climate, and perhaps by cropping system. And organic matter is one of those things we've been talking about for a long time. It's my whole career as a soil scientist, which probably is longer than anyone else dares to remember, that we've been thinking about the importance of organic matter. And there's been lots of measurements, but actually soil scientists need to say we've been too slow at getting the information out in a way that farmers themselves can use to think about and to benchmark where their soils sit. But we've just gone back to the old databases, to data collected in the late 80s through to the 2000s, had a look at that in relation to things like cross-compliant soil types to make that relatively easy. And here, just for an example, for cropping systems in the mid-rainfall region of the UK, to set those targets, is the soil green, amber or red? The answer here isn't that red is necessarily catastrophic, though it would certainly indicate, a bit like a GP does, that we need to make some much more urgent investigations quite quickly if we found a result coming into the red zone. A result in the green means that we're probably about where we would expect to be for that soil. So to show you very quickly an awful lot of data, and the advantage of this approach of summarising organic matter or visual assessment or pH, PKs, MGs, earthworms or anything else is that very quickly, because of the way that data is coloured in, your eyes will be drawn to the fact that, oh, those CO2 respirations all seem quite low because they're all coloured in red. But actually things like phosphorus levels on these soils, well, mostly don't seem too bad. These are all rotations in the set I'm showing you here in late harvested crops, i.e. with potatoes in the rotation dominantly, across a range of soil types, but actually, as you'd expect for these sorts of crops, dominantly light soils with some medium textured soils in there. And actually, phosphorus dominantly green, but both some low numbers and some high numbers. So we've got amber there that are actually at index 14, just pushing into index 1 there, as well as some that perhaps we might more commonly expect on mucked potato ground, where the phosphorus is up into the 50s. But just a quick, not going to dwell on that in any depth, what that data is listed there, and it's sorted into an Excel table that allows me to just sort it quickly and compare, but listed in terms of the order of organic matter in the soils. So those are just ranked in order of organic matter, so from higher levels of organic matter to lower levels of organic matter. The one thing just to note there, I guess, that the eagle eyes amongst you would have noticed is that doesn't mean the green necessarily clusters at the top. Obviously greens tend to be at the top, but there's that one amber, that's that medium soil, which because it's medium in texture, more clay in the soil, should have a higher organic matter than those sandy soils. So although it's got 3.5% organic matter, it's flagging up as being lower than its potential in comparison to perhaps some of the sandier soils underneath. And there, Sophie, I'm aware, is on the call. The top soil on the list there is one of the classic Norfolk black sands, where the organic matter is there and stabilised from long history as a heathland. So we've got those distinct types of soils in there too. So this is just a way of quickly bringing soil data together in a way that helps us to understand it, to share it, and to think about where we might either be clear that our management practices are putting soil into good condition, or perhaps to identify areas that we might need to look into further. The work with the Asda soil health assessment tool takes that information, but couples it to information with about the rotational management. So here, information about cropping, but more importantly, information about the intensity of land management. So the recording now takes data the soil health drops in a little bit lower in the interaction, but I'm just doing one example here for soil sampled last autumn with fairly intensive cultivations across the rotation, main crop potatoes and sugar beet in that rotation, some crop residue returns, some applications of organic materials. It is actually data from a typical farm field, slightly twiddled, but not by very much. And when we run that data through that soil assessment tool, it's using the same sort of benchmarking approach, but in its presentation just presents that in a slightly different way. So now we get scores in relation to our organic materials and land preparation, the use of cover crops here, none, so right at the bottom, as well as the scores for those indicators you saw earlier. It's possible to add in your penetrometer values, Mark, if you have them, but they aren't part of the scorecard, so aren't contributing to this overall quality score. So this field, as it sits, is scoring in amber overall, as for soil health. But the question is, well, what might we be able to do? This is a typical rotation. It's got potatoes in it. Is there anything we can actually do within that potato rotation that's practical and sensible, and how much difference would that make? And the nice thing about the tool is that we can actually go back to that data entry sheet and then have a look. Well, what happens if? What happens if we do things? So in this context, I haven't made any change to the rotation, so I'm still growing potatoes. I've reduced my cultivation intensity wherever it was possible. So that doesn't mean I've taken out ploughing completely from this rotation, though some people on light soils growing potatoes are looking to remove some of that deeper cultivation. Introduce some catch and cover crops into the rotation wherever I'm able to. Rather than simply adding pig slurry, I've also found a local source of compost and added that into the rotation, which really helps with those slower to break down. It's more of a soil conditioning material. I mean, one of the things in terms of chemistry I've done is that soil was, don't know if you noticed, but was low mag index, was in the 30s. I've improved the mag index on that soil, pushed it up to around 70. But otherwise, although these managements in the long term, like the introduction of catching cover crops and compost, might also improve organic matter, I've not actually changed that here, which is at the early point. But you can see already that those changes, whether we think they're really possible or not, have improved our soil health score. So they give us an idea of what might actually be possible and how things might track through time. So the Asda tool, as it's being developed with Asda, actually gives us not just the ability to score the soil we've got, but also to think about what management opportunities there might be. And of course, it's important that as new knowledge emerges from things like the Rotations Partnership, which we'll be reporting in the near future, that updates our understanding here, so that maybe the simple understanding of the role of catch and cover crops here might be updated in terms of their impact. But nonetheless, we're able to take and use that information. And the supply chains are already looking at this as they're funding this piece of work, to think very carefully, and I guess this also comes as a warning, as to whether these things might be requested and asked for. That increased attention in the supply chain now for measures of sustainability, for more attention to soil health, not just the need to tick a box, but also to move our soils and to show that we're able to move our soils into a positive place. And I think it's really important in that context and ongoing work that we're doing at the moment with McCain, looking at actually the fact that potatoes can be grown perfectly well at high health status in terms of soils, as well as in terms of seed and all those other things that we're concerned about. So high soil health status doesn't necessarily mean taking potatoes out of the rotation, but it's important to be measuring and monitoring it to be able to make those decisions. And just to flag up, if you haven't come across them, AHDB is starting to move away from developing these printed materials, but they're still there at the moment. The Principles of Soil Management Guide and the Measuring and Managing Soil Organic Matter Guide, both emerging from that AHDB BBRO project going forward. And also just a reminder to keep your eyes open, not by July, Mark, but in the autumn, for those emerging outputs from the Rotations Partnership and for this other soil biology and soil health partnership into the autumn too.
Thank you, Elizabeth, for an interesting presentation. From the output of the soil health tool, I think you said that the model shows that where cover crops are added to the rotation, they have a significant effect upon the soil health. Do they really add this much benefit?
Cover crops increasing score? The evidence is actually really clear, Graham, that they do on average improve soil health slightly. And so that accumulation over the rotation, the integration, having green cover where it's possible to have it. It's also possible, of course, to do cover cropping really badly, to have untimely practice, untimely cultivations, extra cultivations and so on, that actually can add negatively to a rotation. So obviously the assumption in a model where a change practice is introduced is that that's done well. We always know that it's possible not to do that well. But that in that example I showed you, it wasn't the only thing we changed. I just looked for those opportunities where it was possible, like we do with a reference crop, to introduce a cover crop into that rotation that had previously had none, and also to introduce catch crops because they were quite late sown wheats. So it was possible agronomically to add a catch crop that worked between an early harvested and a late drilled winter cereal. And that just adds to the photosynthesis, adds to the carbon being fed through to the system. I think the biggest change, and we didn't map it, it's the kind of thing it's really interesting to do with the toy, with the tool. You know, actually, I think the biggest change there is from both fixing magnesium, so that made a big difference to the score, so having magnesium in the right index range, but also actually adding some compost to the system. Those slow to break down soil conditioning on those light soils are also, from the evidence drawn from the literature, shows that also has a big impact. So it wasn't just cover crops in there making that difference, it was that combination of changes that were making the difference to that soil health score.